Hi guys, here's our math problem for today. Let's say we have this blue semicircle and let's connect points D and E to form this yellow circular segment of the blue semicircle. Then let's fold this yellow circular segment across line DE this way in such a way that the arc and the diameter of the blue semicircle are tangent with each other. Then let's label the points. If the length of segment AB is 4 units and the length of segment BC is 2 units, find the length of line segment DE. You can pause the video and see if you can solve this Belgian Olympiad problem. Now let's solve this problem together. First, let's locate the center of the blue semicircle. Let's call it as point P. Now, since the diameter of the semicircle is 4 plus 2 equals 6, it follows that the length of the radius is 1/2 of 6, which is 3. So the radius is 3 units. Then it follows that the length of segment PB must be 1 unit. Then let's construct this red circle containing this yellow circular segment of the original blue semicircle. Now, there are two things that we would like to pinpoint when we draw this red semicircle. First, if we draw this line segment P up to the center of the red circle, and if we call this point of intersection as point Q, then we can say that this lower part QP is the reflection of the upper part. And so let's call this point as P prime to indicate it's the reflection of point P. That means the length of segment QP and the length of segment QP prime are equal. And this angle DQP prime is a right angle. Second, since the red circle contains this yellow circular segment of the original semicircle, then the radii of the semicircle and of the red circle must be equal. And if the radius of the blue semicircle is 3 units, then the radius also of this red circle must also be 3 units. Then let's construct this line segment from point P prime, which is the center of the red circle, perpendicular to the diameter of the red semicircle. Since the radius of the red circle is 3 units, then the length of P prime B must be equal to 3 units as well. We now have here a right triangle. The measures of the legs are 3 and 1 unit respectively. Then we can easily compute the length of the hypotenuse P prime P using the Pythagorean theorem. So P prime is now equal to the square root of the square of 3 and the square of 1, which gives us square root of 10. Since QP and QP prime are congruent, then the measure of QP prime must be 1/2 the measure of segment P prime. So the length of QP prime must be square root of 10 over 2, and the length of QP must also be square root of 10 over 2. Then let's connect this point P to this point of intersection D. Now, since P is the center of the blue semicircle, then PD is a radius of the semicircle, and its measure must be equal to 3 units as well. So we know the length of the hypotenuse, we know the length of one of the legs. We can now compute the length of the other leg, DQ. The reason why we are solving for the length of DQ is because DQ and EQ are also congruent. The line segment P prime is the perpendicular bisector of DE. So if we can find the length of DQ, then we can just double its measure and we'll find the measure of segment DE, which is what we want to find in this problem. So let's solve now for the length of DQ using the Pythagorean theorem. So DQ is equal to the square root of the square of the hypotenuse, which is 3 squared, minus the square of the leg, square root of 10 over 2. 3 squared is equal to 9. The square of the square root of 10 is 10, and the square of 2 is 4. And simplifying, we arrive at the square root of 13 over 2. At this point, there's no need for us to rationalize this. So to find out the length of line segment DE, we just need to double square root of 13 over 2. So doubling square root of 13 over 2, we arrive at square root of 26, or approximately equal to 5.10 units. And this is now our final answer. The length of the folded line DE is rounded off to 5.10 units. And this is a very neat problem. So thank you very much, and we hope to see you again in our next video.